All right, so today is going to be a continuation of yesterday's lesson, which is completing the square. Today I will be going through like the different types of solutions that you can find and how we can use completing the square to figure out solutions for. So I use the word quadratics, and I want to make sure we're on the same page with what a quadratic is. Quadratic is a second degree polynomial. So everything that you see here is an example of a quadratic because the highest degree of these polynomials is power 2. See, power 2. There's my power 2, power 2, power 2. So every last one of these are examples of what we call quadratics. All quadratics, I don't care what type you're looking at, I don't care what the numbers say, every single quadratic makes a special shape, and that shape is what we call a parabola. So if you look at this drawing, all of these are examples of parabolas. Now remember, parabolas make a U shape. Now they can be concave up or they can be upside down. They can be real narrow, they can be real wide. Just as long as it's a variation of a U shape, you have a parabola, upside down or very narrow, very wide. So I have 3 different types that I drew up here. So there's different techniques that we can use to find solutions. When I have a parabola, any type of parabola, solutions basically happen whenever we touch the x-axis, this line right here. This one touches twice, that means this one has 2 solutions. This one touches the x-axis one time, it has 1 solution. This one touches the x-axis 0 times. Now, we say that this one has 0 solutions, but the truth is it does have solutions. We just call them imaginary or they're complex. All right. So 2 solutions, 1 solution, complex solutions. All right. So I have an equation, x squared plus 4x plus 4 is equal to 25. For this one, we're going to find solutions. So I'm going to skip over some stuff and just go straight into it. I'm just going to let you know up front that this right here is what we call a perfect square trinomial. This is the same one that I worked on from yesterday. So from yesterday, we know that that's what that actually means if we were to condense it. Now, I could set that equal to 25. So far, I've condensed this side of the problem to this. And then from here, this is how we began solving. Now, all I have to do now is take the square root of both sides, all right? When I take the square root of both sides, this gets rid of the second power, and now I can bring down the x plus 2. This one could be either a positive 5 or a negative 5, all right? And we'll get into that reason at some other time if you don't already know. Now, this plus 2 can be subtracted to the other side. And what I get is a minus 2, and then I get a minus 2 there. See that? That allows me to get rid of it over here. And what I have is this funny or weird looking statement that basically gives me 2 different solutions. I can do negative 2 plus 5, and that gives me a positive 3. Or I can do a negative 2 minus 5, and that gives me a negative 7. So there are my 2 solutions. X is equal to 3. X is equal to negative 7. All right, so if you take a look at it, I have my x squared plus 4x plus 4, and then I have my 25. I'm going to tell the calculator, I was about to say computer, same thing, to draw it. And there's my parabola, and there's my 25 that's going straight across. Now, if I look for the intersections, it's going to find where they hit. And look at that. X is equal to negative 7. That's one of my solutions. And the other one was positive 3. So what we have found we found out through graphing when does this and that intersect each other. That's what the equal sign is for. When things are set equal to each other, that's when they hit. That's when they. All right, so we're going to solve this problem by using completing the square. Same technique as I used yesterday. I'm going to use a more visual approach, but this is a problem that we're going to use when we do it. Did you all notice the first step? The first step is going to be your important step. All right, so what happened was that plus 7 was on the left side of the equal sign. By subtraction, I was able to get it to the right side of the equal sign. And what it created was a blank spot where it used to sit, all right? That's what we mean by completing the square. We have to complete this to turn this into a perfect square trinomial. All right, so remember we have our x times x. This one has to be split evenly. So that's why I have an x minus 6 this way and I have an x minus 6 this way, all right? And remember, what we have to do is complete this square by completing in all of these boxes. All right, so here we go. X times x, there's my x to the second power. I have x times negative 6, that's my 6x. I have negative 6 times x, there's my negative 6x again. And remember, a negative 6 times a negative 6 is a positive 36. Complete the square. All right, so we completed it. All right, since I added in a 36 to complete my square, if I put 36 on the left side of the equal sign, I also have to do the same thing on the right side of the equal sign. That's the only way you can keep things in balance. And remember, the whole point here was to be able to take this problem and shrink it into this. We needed it to be a perfect square. Now, over here, if we do the math, that's basically your 36 minus 7, that's your 29. So now we're at a point where we can start finding our solutions. So remember, we take the square root on this side. Basically, what we have is the x minus 6. Remember, this one comes down. It could be positive or negative square root 29. And then remember, this can go over there. So I can take this negative 6 and add it to the other side as a positive 6. Therefore, my final answer will say x is equal to 6 plus or minus square root 29. X is equal to 6 plus or minus square root 29. All right, so I'm about to run through this one all the way across. So I have x squared plus 8x minus 11 is equal to 0. So we start off with a problem, and we're going to use completing the square to solve it. First thing that needs to go, we need to get this 11 across the equal sign. So that's a positive 11 when I move it. Okay, so that's the first move we make right there. Now, here, this is where I'm going to use my diagram. The diagram is going to look like a square. And I know that I'm going to have x and x. Then I'm going to have a 4 and a 4. And I need both of those to be positive. So let's think about it. We got x to the second power. I multiply again, I get a positive 4x. I multiply for this one, I get a positive 4x. That times that is a plus 16. I completed my square with the plus 16. So that means up here, I can do plus 16 and I can do plus 16 again. Now, remember, that's an x plus 4 twice. So I'm going to get rid of my box because I don't want to. That means this changes formats to an x plus 4. Now I have it written a special type of way. Over here, 11 plus 16 is 27. So now we're to the point where we can solve again. All right, so we square root both sides. Square root both sides. And what I get here is x plus 4. And then over here I get a plus or minus square root 27. Now there is an actual way that we can simplify that. I'm just not going to do it right now. All right, so here we go. We got the plus 4. I need to get that over there, right? So this plus 4 comes over here as a minus 4. So my final answer is going to say x is equal to negative 4 plus or minus the square root of 27. This isn't the simplified answer, but we can work on that later. I just want to make sure that we can get to that variable. If we can get to that variable, we can simplify this later. So here's your simplified answer. I can go into that later. I just wanted to make sure I did write down the simplified answer. So those are only examples I wanted to go over today. If you can get those, you pretty much have the fundamentals to completing the square. Now remember, completing the square is one of the ways that we can use to solve quadratic functions. Any of them, right? And then that leads us into something called a quadratic equation, which basically does all the work ahead of time. All you have to do is just crunch numbers. All right, you can search me on YouTube right there by that spelling. You can look for this picture. This is where I am every day. I'm putting up videos. You can subscribe here, get more math videos. All right.